Hey guys, I was asked to make a couple of videos to help with some of the surface area stuff. So we're going to focus on surface area of pyramids and some cones. So we came up with the formula in class, right? We developed it together by unfolding it, or I pushed it against the whiteboard and made it fall down basically, and we broke down all the areas and we came up with this formula. Surface area for the pyramid was big B plus 1/2 P times L. And big B, of course, is the area of the base, which we've used before, of course, when we did prisms and cylinders. So big B for this picture, which was the first example on the notes page, is a triangle, an equilateral triangle here on the bottom. And the 1/2 big P was 1/2 the perimeter. Perimeter, of course, of the base again. So in this case, it'd be the 9s, 9, 9, and 9. And then, of course, the slant height, which is the italicized kind of lowercase script L thing. Again, we usually use this because if you just write a lowercase L like it would show up normally, it would look like a 1. So we write it this way so people understand what's what. So that's the slant height, just to be sure. This is the perimeter of the base, and this is the area of the base. And notice I'm using big B so that you don't confuse that with just like the base of a triangle. Right, and we're going to see that in a second because that's usually what most people have trouble with. So when I'm doing this particular example, I want big B, but big B is a triangle. So the formula for area of a triangle by itself, of course, area of a triangle is 1/2 base times height. But I'm using the word base, but I'm referring to little b. This is the base of just the triangle, not base of the prism. Okay, if it was the base of the prism, it would be a big B. Or in this case, sorry, pyramid, but it's the same big B. Okay, so big B is the area of the base of whatever it is you're using. In this case, we're going to do it for a pyramid. So in this case, I'm going to do 1/2. The base of the triangle is 9, and the height of the triangle is 7.8 right here. Okay, so 9 times 7.8 times 7.8 plus 1/2 the perimeter of the base, and the perimeter of the base is 9, 9, and 9. So that's 27. Times the slant height, which is conveniently given to us at 11.3. Okay. Notice again, I'm using the word height here, but I'm not talking about the height of the prism. The height of the prism, of course, would be from the top of the pyramid. Would be from the top of the pyramid straight down to the center of the base. Okay, of big B. So that's not even drawn in here, but that's where it would be, right here. Now, this the red dashed line on the right here is slanted from the top of the pyramid down to the center of the edge of one of the sides of the base. Okay, so it's perpendicular to one of the sides of the big B. So that's a little bit different. That's why it's the slant height. It's literally slanted. Okay, and then we obviously would just let our calculator do the rest here. And I think I remember in class we got around 187. I don't know, it was like 0.6 or 0.7, something like that. This is more important though. If you can do the setup, obviously I can trust your calculator skills. So here's the setup, which came straight from the formula we developed in class, and that pretty much takes care of your basic pyramid. Okay, let's do one a little more complicated because I think some people had trouble with this second one. This is straight from the notes page, the one we had in class there, and this was the pyramid here. Okay. So in this example, I'm still doing a pyramid, so it's still going to be big B plus 1/2 PL, and big B in this case is probably a little easier actually because it's just a square, 8 by 8 by 8 by 8, right? So 8 times 8, of course, is 64. That's the area of the square, plus 1/2 the perimeter of the square, and 4 eighths is going to be what, 32, times the slant height. Uh-oh. I don't see the slant height shown here. I see a height of the pyramid itself directly, the 12, but I do not see the slant height. So here's, you got to do a little bit of old school, geometry here when we were doing right triangles. You can kind of see all the right angles in the picture, but in this case I've got the 12. I've got this that I'm trying to find, which is the hypotenuse of a right triangle that's not actually drawn yet. So let me just kind of sketch the triangle part and see if we can piece it together. Okay, so this is the 12. So this part right here, I'm representing the height of the pyramid itself. This part, that's my slant height from the picture. Okay, so this part right here is the same as the blue part right here. So this is 12. This is unknown. We're trying to find that. And the only piece I'm missing is down here. Right? It's a right angle. Right? Here's the right angle right there. So it's 90 on both sides, of course, because it's 180 total. So what could I do here? Well, 8 is all the way along one edge of the base of the pyramid. So if I'm in the dead center of that pyramid and I go to the edge, wouldn't that be exactly half? So wouldn't this actually be 4 centimeters? Okay, let's look at that again. Technically, I mean really, actually this might be easier to see. I could draw both triangles if you want. Right? If I do that, if I draw both triangles, that is literally the slant height on the left all the way across to the other slant height and then back up to the top. That's what that would be. And if I go down right through the middle there, well then I'm splitting this 8 centimeters in half. And that's where the 4 comes from. So when I want to find this slant height, I have to do a little bit of extra work. I got to use Pythagorean theorem to figure out that actual slant height. So I'll do that over here. So actually I'll do it underneath. 4 squared plus 12 squared equals my slant height squared. You want to call that x, that's fine, but it's it's just the slant height. So I'm going to use the same L. So 16 plus 144, that's 160. That's not a perfect square, nor do you need to do simplest radical form for something like this. You can just go right to the calculator. I think it was around 12 and a half, almost like 12.6 when you take the square root of both sides. And now you know what the slant height is, and it can go right here. So sometimes it takes a little extra work. Okay, it didn't on the first one, but it did for this one. So once you get, of course, all your pieces, we have everything filled in, we're ready to go. I believe we get about, I think it was about 266, give or take. Okay, and that's how you would do one like that. Okay, so I think I'm going to stop the video here. We did 2 pretty good examples for pyramids. Let me know if you have any questions. I'll make another video with at least one example of a cone. Okay, all right, let me know if you have questions. I'll talk to you later. Bye.